All right, so in this lab, we're going to be making a lot of our own glassware. So the first thing we're going to make is stir bars. So in organic chemistry, a lot of the time we'll have some kind of beaker or something filled with some kind of liquid. And we want you to stir this liquid continuously, maybe for a couple minutes or maybe for a half hour to a whole hour. And so as you can imagine, be a pain in the butt to stir this thing continuously. And so what we use instead is a magnetic stir plate. So this right here is my stir plate. And it's got some knobs on here. One of these knobs controls the stirs. And inside this stir plate is a little magnet. And when you turn on the stirring function, this magnet will spin. And so what we do then is put a piece of metal inside of our beaker. And because this is magnetic as well, when the magnet in the stir plate spins, our stir bar will also spin. And so, right, we need a piece of metal. The problem with this piece of metal is that it's reactive. If we just put a piece of metal in there, it's going to react with our components and then change our experiment. And so what we need to do is coat this in some glass. We need to encapsulate this piece of metal in some glass because glass is unreactive. And so in this video, we'll show you how to make some stir bars, and you want to make about 5 stir bars for your use throughout the semester. All right, so in organic chemistry, we're going to be doing a lot of stirring, and it's going to be really hard to do this all by hand. So what we're going to use instead is a magnetic stir plate. And so inside of here is a little magnet, and then when we turn it on, it spins, right? And so what we're going to do is if we have a beaker or whatever we want to stir in, we're going to put in our little stirring rod. And this stirring rod right here is a little piece of paper clip, so a piece of metal encased inside of a piece of glass. And so you put the stir bar in the beaker, and you can see it's attracted to the magnet in the plate. And then, we would have some kind of liquid or something in here. We'd turn on the stir, center it up, and then it's going to stir for us. And so the first thing we have to learn is how we're going to make these little stir bars. All right, so the first step here, we're going to mess with this pipette here. And so you can see this open-ended pipette. And so the first thing we're going to do is we're going to use the flame to close the end of this pipette. So we have our Bunsen burner right here. So we're going to go ahead and turn this to off. You see how it's open there. Close that so no air gets in. Turn the gas on. Use your lighter to light the flame. And then open up this bottom part to let more in and get a more intense flame. Next thing we're going to do, we're going to place the tip of this pipette into the flame to melt the glass and close the tip. So we're going to go from a downward angle, and the way I like to do this is to use 2 hands. One hand is just going to hold the pipette, and then the other hand is going to do a little rotation. So kind of something like this, right? Except in the flame. So let's see how this goes. And you just want the tip of the pipette in the flame. And just rotate it about. Until you get a nice closed bulb on the end of the pipette. And that's it for the first step. All right, so the next step, we want to go ahead and put a piece of metal into our stir bar and then close it up. So for our metal, we're going to be using this paper clip right here. And basically, we're going to cut off about a 1 centimeter piece. So somewhere right about here. And we've got our piece of metal. Next up, you're going to insert the piece of metal into your pipette. So through the big end, just drop it in. Right, and you can see it down there on the bottom. Next up, to the open end of the pipette, you're going to insert a hose that goes through the vacuum. And then you're going to turn the vacuum on to suck the air out of the pipette. Turn your flame back on. And so now with a piece of forceps, or with some forceps, you're going to hold the metal piece, and then you want to touch the flame right about to the end of the metal. And so that's going to close out this bar, and then once it starts heating up, you want to pull the pipette away with your right hand. So you're going to keep the metal piece in the flame, pull away the right side. And then just let it sit in the flame for a little bit, and you'll end up with a tiny little kind of bulb hook thing. And there's your stir bar. So one of the first things we're going to learn about our compounds is their boiling point, right? Something we can do with liquids. So what we'll have here is a capillary. And I've drawn it very big, but in real life, you'll see it's actually very, very small. And then inside this tiny capillary, we have to make an even tinier capillary bell, which will just be another capillary, except with this kind of closed off fused end. So this is just this kind of dark black area is just a chunk of metal or a chunk of melted glass, right? So this will be the capillary bell. And we'll be making that. So you'll see in the videos how you make that. Basically, we take a pipette, put in some fire, pull it really thin, and then close off one end. And so after this, we're going to fill it with some liquid. We want to make sure the liquid does not go over top of the capillary bell. As you'll see in the videos, you make some mistakes, but that's totally A-okay. And then you also want to make sure that this section of the capillary bell is weighted enough. If it's not weighted enough, basically your capillary bell or just move above the liquid and you won't get a good measurement. And so after we've got our capillary and capillary bell and our liquid in here, we're going to put this in a melting point apparatus. And so what this is going to do is going to heat this liquid nice and evenly. And as a liquid heats, its vapor pressure will increase. And so we'll get a bunch of vapor here, right? We're going to essentially evaporate or boil this up here, right? So once the vapor pressure becomes strong enough, or as strong as the atmospheric pressure, we observe boiling. And when you'll see boiling, there'll be very rapid bubbles. So not just one or two, but very rapid amount of bubbles coming out of here. And so that tells you that it's boiling. Very fast bubbling. And so it's hard to tell when the fast part occurs. So we'll see in the video that some bubbling occurs, but it's not necessarily boiling. It's not until we're going very fast that we're actually boiling. I think if you boil a pot of water, right, you'll see some bubbles form here and there, but it's not really boiling until it's got that roaring boil. And so what we'll do basically is just overshoot this. We'll go beyond the boiling point, or we'll have very fast bubbling. And then when we're sure we've got the very fast bubbling, what we're going to do is just turn off the heat. And then it's going to cool, right? Once we turn off the heating in our apparatus, it's going to cool. Once it starts cooling, the bubble is going to start slowing down. And so we want to read the temperature when either the last bubble comes out or when the liquid starts filling the capillary bell again, depending on which source you read, right? So read the temperature when the last bubble comes out / when the liquid starts filling the capillary bell. At this point, when this occurs, you know that your vapor pressure is equal to your atmospheric pressure, right? Because your atmospheric pressure is able to push this liquid back into the capillary. And that's the definition of boiling. Remember, boiling is not a set temperature. Boiling is dependent on the pressure of the system, right? So the true definition of boiling is when vapor pressure is equal to atmospheric pressure. And so we'll see 3 different samples being run at the same time. and really the center sample is going to be the best. And the reason the center sample is the best is because I had a good weighted capillary bell on it, right? So this chunk up here was heavy enough to stay down, and I didn't overfill the liquid, right? So I made some mistakes on some other two ones, but that's all part of the learning process. And so when you're taking these, sometimes it can take quite a while to get up to your target boiling point. And so it's up to you how you want to handle it. You basically have two options. One, you can go slowly the entire time, which is what you'll see in the video, and it still only takes about 10 minutes, which is totally fine. The other option is you can go quickly and really jack up the heat a bit, but then you're going to overshoot your boiling point by quite a bit, and then you're just going to have to wait longer for it to cool. But either way kind of works. I would just suggest just going slowly the whole time. Or if you have a known boiling point, you can go quickly till you're about 10 degrees below its known boiling point and then slow down. But overall, I wouldn't mess around with it too much. My suggestion is just to go slow from the beginning. All right, so first thing we've got to do is make our capillary bells for our capillaries so we can do micro boiling point. And so this is our capillary. You can see it's a very thin tube, and so we need to make a tube that's thinner than this to fit in the capillary. And so the way we're going to do this is we're going to take one of these big old honkin' pipettes. We're going to heat the middle with the tip of the inner cone, and then we're going to pull it apart. The trick here is, let me readjust this camera a little bit, is while this is in the flame, you want to start your pull. So start pulling them apart when it's in the flame, and then just remove it and continue your pull. And really this is just practice, practice, practice. There's no kind of one trick to get this right. It's just practice. And if you come in here with a good attitude, it's actually pretty fun. It's like a black glass blowing glass. So we'll start heating. Use that tip of that inner cone. Rotating the pipette so we get nice, even heating. And you can see it's getting a little bit more malleable. See how I can kind of twist it and bend it. Let it get more malleable. It's pretty decent. And now I'm going to start my pull in the flame, continue the pull in the flame, and then just pull it out for that last little pull. And ta-da, there's our finished product. One thing you have to remember is that hot glass and cold glass look the same. So while it might not look hot, it is hot. If you're like me, this is going to be a lesson you're going to learn many times. And so if we compare this with our capillary, you can see that this tube is indeed smaller than our capillary. All right, so we've got our pulled pipette, and now we simply just pick a spot to break it off in. Remember, it has to be thinner than this capillary, so you don't want to break it off right here because that's too thick, and so that part's going to be useless. So just find a nice kind of thin part and simply break the glass off. And then ensure that it does indeed fit into your capillary. And you can see this one does indeed fit into the capillary. And so we can make a couple of bells out of this. All right, so for making these bells, here's the technique I've been using. So you got your thin piece of glass here, and then you're just going to shove a good bit of it into the fire. And then it's going to kind of make a hook, right? So if you keep this hook, it's not going to fit in the capillary. So you just toss it the opposite way and then reheat it, and that hook will straighten out. And now you can test whether it will fit into your capillary. And this one does, so it'll be good. You can see I'm starting to get too thick of glass over here, so that's probably the end of the bells for this pipette. Probably too thick on this end to really use a bell. Let's check it out. Yeah, you see it fits in there, but not quite good enough. Too thick. All right, next up we need to fill our capillary with our liquid. So for this case we're doing ethyl acetate, so a known, to make it nice and easy. So of course transfer some into a secondary container. Never pull from the primary container, otherwise you may contaminate it. That'll be more than enough. And then what you're going to want to use is one of the pipettes or the bits of the pipettes of one of the ones you pulled. If you use a regular pipette, it's not going to be thin enough to fit into the capillary. And so simply just suck up a tiny amount, like that's way too much. You don't need that much. Stick it in your capillary tube. If you can, go all the way to the bottom. It's not totally necessary, but it'll make things a little bit easier. And then just simply shoot out some liquid. You can see because of the capillary action, it's not all going to go to the bottom right away. You see there's a little air bubble there? That's fine. You can just tap it down here. There you go, a little flick, like you've seen doctors do. It's a chance to be a doctor. And there you go. Now it's filled. And now we insert one of the bells that we made. And so you want the open end down. And so I've actually probably put too much liquid in here. You see our bells just barely taller. So you probably want even less liquid than that. So just get our bell in there. Tap it down. You can use your pipette to push it down if you need to. See, I made this bell a little too angular to fit in here very well. And just push it down, and now you've got your bell in there. Let's try another one. We'll insert less liquid this time. All of this stuff is really about practice, practice, practice. You just got to go in there, get your hands dirty, and start doing. See, this time I did better, put less liquid in there. Get one of our bells. Let's make one more. This time I'm going to put a very tiny amount of liquid in here. Put our bell in. You can see for this one, the liquid is well below the bell. So through trial and error, we'll find out what works the best. All right, so for our boiling points, we'll be using these melt temps right here. Over here on this side is the on or off button. That'll just turn on the light switch and the heating. You control the heat by this knob. 10 is max heat, and you pretty much never want to go to 10. And then 0 is off heat, right? So you really want to go slowly, not too quickly with this. In terms of, right, this isn't in temperature, so you're just going to have to play around with it and realize what temperature it is. The thermometer comes up here, goes inside the instrument, and then we load your sample inside the instrument. So this is going to be a little bit hard to see, so I'll turn it on so the light is on. And down here you can see there's 3 little slots, 1, 2, 3. That's where you're going to put your samples in. You can hold up to 3 samples at a time. And so you insert your sample into there, and then you look through this glass right here, and we should see our sample, right? You see our sample right in that middle slot that we placed it. So that's what we're going to be watching. All right, another thing we're going to want to know about our compounds is their density. So remember that density is equal to mass over volume. And so if we're thinking about how we're going to measure these two aspects, mass is pretty simple. We're going to weigh it. But volume gets a little bit more complicated in that we need to be quite precise with our volume. So we can buy a good scale, and so we can get the weight quite accurately. But the volume, you can't just use a graduated cylinder. It's simply not accurate enough. So instead, what we're going to do is we're going to use a pycnometer. And so this is just an instrument used to find the density precisely. And in our case, we're just going to make our own. So you'll see how we make it in the lab. Basically, all it needs to have is some kind of big bulb open side, and then some kind of smaller, skinnier upside where there can be some capillary action occurring. And so the first thing you're going to do is you're going to weigh this empty. So that way you know the mass of your empty pycnometer. And then you're going to fill it up with some kind of known compound, something that you know the density of. And this is where the capillary action comes in, because the liquid will fill up to the top of the capillary and no more, no less. So you can get the same amount of volume in every time, right? So we're going to fill, in this case, with water, because we know the density of water, and then we can weigh it. And so in our case, for our lab, under the circumstances we're working at, our density of water is going to be 0.99705 grams per milliliter, right? And so if we know the mass of the water, we can then convert that to our volume, right? And so now we've got half of the equation. We've got our volume figured out. After this, we're going to empty the pycnometer of the water. And then after that, we're going to rinse with acetone, which is this molecule right here. And the reason we rinse with acetone is because acetone is very volatile, which means it turns into a gas quickly, and so it's going to dry quickly. Right? If you don't add the acetone in there, you're going to have some leftover water that's going to mess with your measurement. So just squirt some acetone in there, shake it out, and then let it all evaporate away. And then fourth step, you're going to fill with your compound of interest, and then you're going to weigh it up. All right, so you got your pycnometer in there, fill in your compound of interest, and then you calculate the mass component, right? Now you know the mass, you already knew the volume, and so you can find the density of your compound. Seal off one end. Cut off the other end. Once the glass is cooled, And then just use your flame to smooth out the end. But don't seal it. Alright, next up we'll want to weigh our empty pycnometer. So just gotta put the weigh paper in there, tear it, and then weigh your pycnometer. And you'll want to write this weight down. Next up, we'll want to fill our pycnometer with something that we know the density of, such as deionized water, which I have here. So simply take a pipette and fill your pycnometer to the top. And then I got water on the outside of mine, so I'll just take a paper towel and wipe out the outside. Of course, make sure it's filled to the top. Cool. So now we'll weigh our pycnometer filled with water. So I got a little 10 ml beaker in there teared. Simply place it inside. And record our weight. All right, next up we empty the water out of the pycnometer, so you can just kind of shake it a little bit, use the pipette that you used to get the water in there. And then we can rinse it out with a little bit of acetone. So just get it in there and then get it out. And then you want to wait for this to fully dry. And then we fill our pycnometer up with our ethyl acetate in this case, or whatever compound you're studying. Wipe out the outside and weigh your pycnometer. And then we want to record the mass of our pycnometer filled with the ethyl acetate. So we have our balance set to 0. And then we record this weight. All right, so the final thing we're going to practice today is getting the melting point of a compound. And so this is kind of actually a little bit confusing because a melting point actually isn't a point, it's a range. Right, it's actually a range, not a point. And so you can use melting point to identify compounds, right? If you want to know, hey, is this, say, caffeine, right? Caffeine melts at a specific temperature range, and so you could melt yours, and does it match with caffeine? Another thing you can use for it is to determine how pure a compound is. So think back to Gen Chem, colligative properties, freezing point depression. Not only do impurities depress or lower the melting point, but they also broaden it. So a pure compound will melt within probably 1 to 2 degrees Celsius range, whereas an impure compound will have a much broader melting point range. And so similar to our boiling point, we're just going to put this in a capillary. This time we don't need any bell or anything fancy like that. So you're going to fill it up with your solid. And you don't want a lot of solid because then you're not going to get even heating. So this should be less than or equal to like 2 millimeters. You want to have enough so you can see what's going on, but not too much because otherwise you're not going to have good heating, right? The good heat is really only in the first kind of 2 millimeters or so. And then you're going to let some time go by. And what you might observe is that your solid starts kind of shrinking. It shrinks away from the walls. And so a lot of people think this is melting. This is actually not melting. So if it shrinks, right, this is not melting. This is a process called sintering. Basically, the individual crystals are fusing together. So it's not actually melting yet. The next thing that you might see is that it looks like it's sweating. So you might see kind of like it's wet, but it's not still melting, right? This is just called sweating. Again, this is not melting, right? So don't be fooled by that. You want to let some more time go by. And we're going to read 2 numbers, right? Because it's a range. We want to read when it starts melting and when it stops melting. The first number you want to read is when you first see any amount of liquid down in the bottom, right? So when you see that kind of first drop form. So you see liquid, you read the melting point, and that's your first number, right? First of your range. And then you let some more time go by, and you wait for it to all melt, right? Once it's all melted, then you read your second melting point. And so at the end in your lab manual, your melting point should be a range, right? You should go from number 1 to number 2. And make sure you're reading the thermometer to the correct number of sig figs. If you have any questions, let me know during lecture or lab. And then the final thing that we always want to do in lab, we always want to write what happens. Not what you want to happen. So sometimes you're going to get some results that maybe you don't like, or that maybe don't agree with what you read in a book or something like that. There's always experimental error, instrumental error, off in calibration. But what's important is that we write what actually happened and not just what we want to happen, right? We want to identify any mistakes or any sources of error. All right, so next up, we're going to take a melting point test. Here's our compound. What we're going to do is fill some up in a capillary tube. So first off, I've poured some of the crystals into here. We'll grind them up into a nice powder to be able to get them into our capillary tube. And then simply dab the open end of your capillary tube and try to pick up some of this solid. And then you can just dab it on the table to get it down to the bottom. And now we're ready to take our melting point. All right, so we're going to take our melting point test using this melt temp. So what you're going to do is insert your capillary into the sample holder, which is right around here. Turn it on, and then you're going to start increasing the amount of heat added while looking through this glass and wait for it to melt. Once it starts melting, you want to go ahead and make a quick reading of your temperature.